All right, sorry about that. Welcome to our webinar on configuring HOBO weather stations. My name is Paul Gannett, and I'm Product Marketing Manager here at Onset for our environmental products. Today I'll be going through the 5 key questions that you can use to help configure weather stations for your applications. These can be for stations that you are deploying in remote parts of the world or locally to gather weather data for building energy studies. All right, here's what I plan to cover. First, I'll start with a brief overview of Onset and our weather stations. Then I'll get into the meat of our webinar, the 5 key questions. I have allowed some time at the end to address questions. You can send your questions at any time during the presentation, and I'll get to as many of these as I can at the end. First, a little bit about Onset, for those of you who don't know us. We are the company that makes HOBO data loggers, which are used around the world. We've been around since 1981, which makes this our 30th year in business. We have about 130 employees here on Cape Cod, Massachusetts, which is where we design and assemble all of our products. The main markets that we sell to are field research, water management, and energy management. Everything we do is related in some way to conservation, be it finding ways to protect our environment or saving energy. Before getting into the 5 questions, I'd like to give you a brief overview of the HOBO weather station family. The challenge of configuring a HOBO weather station is that it is kind of like going to your favorite ice cream shop. There are a lot of good flavors to choose from. Here's an overview of the common features of the HOBO weather stations. All of our weather stations are easy to deploy with no programming required and no complicated wiring. The smart sensors are plug and play, which means you just plug them in and the logger recognizes the sensor and displays the data in the correct units. Likewise, for our web-enabled stations, you just connect the power source to the station and it automatically connects to the internet. Once it is connected to the internet, all your setup and monitoring can be done from the web. We also try to keep our costs down, with standalone stations starting in the few $100 range and web-enabled stations for under $2,000. I'll get into more specifics on the cost later. All of our stations provide research-grade performance and will last for years in harsh environments. The good news when choosing between our stations is that they all use the same set of smart sensors. So basically, you are just choosing between stations based on number of inputs and how you want to access your data. I should also mention that our weather stations are complemented by our HOBO Standalone Loggers, which can be thought of as mini weather stations. These loggers can be used to get a picture of the spatial variability for key weather parameters such as temperature, humidity, and rainfall. The data from our standalone loggers can be graphed and analyzed together with our weather station data with our HOBOware desktop software. Just to give you a little feel for some of our standalone loggers, we have a temperature and humidity data logger here with the sensors built in. This is our pendant temp and light logger, and this is our rainfall logger, self-contained rainfall data logger. We also offer a couple of wireless sensors that transmit data to a PC. The data from these can also be combined with weather station data and looked at with our software. Okay, now it's time to get into the main part of the webinar, the 5 key questions. The first question to ask is, what are the advantages of having site-specific weather data? In other words, what are some of the reasons that you might need a weather station? One of the main areas where weather stations are needed is for gathering weather data at remote sites where there are not any other weather stations. This slide shows some examples of sites where HOBO loggers are deployed that are well away from any other weather stations. Or in the case of Boston Harbor, it is remote in the sense that it is tracking conditions beyond what is provided by the standard weather service stations. Understanding conditions in these remote sites is especially important now as scientists try to understand the impact of global warming. Another advantage of site-specific weather is that climates and conditions at your research site can be very specific to your site. Here are some of the factors that can make the conditions at your site unique. First, looking at topology, we've all seen the effect that mountains can have on weather, such as rain falling on one side and not the other. And even on a smaller scale, the temperature can vary on one slope of a hill versus the other slope of the hill, whether it's facing the sun or not. Bodies of water can also have a significant impact on the climate conditions near them. For example, in the area near Buffalo where I grew up, all the vineyards were located along the banks of the Finger Lakes because the lakes moderated the temperatures just enough that the grapes wouldn't be damaged by a sudden frost. Vegetation can also make a big difference. For example, it can affect how much the soil warms up during the day and the amount of radiation cooling at night. Variations in the soil type don't really affect the weather, but they can lead to large variations in the amount of moisture held in the soil, which for crops can be just as important as the weather. Another reason that you may need to have your own weather station at your site is that one site can have several microclimates within it, and you will need multiple stations to adequately profile the conditions at the site. For example, soil moisture can vary dramatically in a field with elevation, soil type, and where the irrigation lines are. In this case, you might want to deploy your systems like the ones are shown here. In this case, we have a central station which has wind speed, direction, light, temperature, humidity, and soil moisture. And we have two smaller stations, one at a low point in the field, just monitoring temperature and soil moisture at that point, and then another one at a high point in the field, which is monitoring temperature and soil moisture at that point. This is a very common scenario to have multiple stations, especially for parameters that can vary within an area, such as temperature, rainfall, and soil moisture. And for all of you doing building performance testing, you usually need to know what the weather conditions are. That is the only way to know whether an AC unit was running overtime because the weather was hot outside or because the AC unit has a problem. You could try to get weather data from the nearest airport weather station, but as we show here, the weather at the airport can be very different than the conditions at your building. Here's a comparison from a day last week between the temperature at Onset and the nearest airport weather station. This line here, this upper line is the temperatures here at Onset, and this dotted line is at the airport. You can see the temperatures during the day got quite a bit hotter at Onset. The other thing you'll notice is that the data from the airport is only hourly data, so you're getting kind of a very crude picture of what the temperatures were, whereas by having your own weather station on site, you can get a very detailed picture of what was happening with the conditions. The other advantage of deploying your own weather station is that you can get the data in a form that is a lot easier to combine with your energy data. Because we provide both weather stations and energy loggers that use the same HOBOware software, you can easily look at the data together in HOBOware from both of those. If you're doing renewable energy, you have a similar need in that you need to monitor both the weather conditions at the site and the energy generated and look at them together. Okay, enough on why you might need weather stations. The next question you need to ask is, what parameters do I need to monitor? The reason for asking what parameters you need is that these will drive what sensors you need. So first, to decide what parameters, look at it the following ways. First, I like to look at what are the primary parameters that you will be studying. For example, you could be looking at soil moisture versus various irrigation schedules. In this case, soil moisture and irrigation system pressure are the primary parameters you need to measure. The second area to look at is what baseline data do you need. This is the data that you will use to normalize your primary data for conditions during the experiment. These are the parameters that you need to know so you can compare between different sites or different time periods, which might have had different weather conditions. Continuing with my previous example of looking at soil moisture versus irrigation schedules, you would probably also need to know the temperature, wind, and rainfall during your experiment because these can also affect soil moisture. So temperature, wind, and rainfall would be what I call your baseline parameters. The third area to consider is whether the parameters you need are uniform over your experiment area or if they can vary. If the conditions can vary, then you probably need to monitor at multiple locations across your research site. So going back to my irrigation scheduling example, If the research plot is over a uniform flat area, then you probably just need one station with a wind sensor on it for capturing the wind data. On the other hand, rainfall can vary, so you would need multiple stations with rainfall sensors so you know how much rain happened in each area. Temperature may not vary that much, but it is a relatively inexpensive parameter to monitor, so it would probably be worth including in all of your stations just in case there are any variations. Once you know what parameters you need, then you can proceed with selecting your sensors. For selecting sensors, you will need to determine their performance requirements, because I should point up there, which includes things like accuracy and measurement range. Then you'll also need to determine the operating range. This is what the sensors must survive, potential worst-case temperatures. Will they get immersed in water? Do they need to be waterproof? Those are your operating range. And then down here, ease of deployment. That's not really a requirement, but it sure can save you a lot of time and frustration. So certainly it's worth considering the ease of deployment of your sensors. On the next slides, we'll look at your sensor choices for HOBO stations. For HOBO stations, your sensor choices basically fall into these three categories: smart sensors, analog output sensors, and pulse output sensors. In most cases, you will want to use our Onset smart sensors listed here, as these are the easiest to configure and they provide good research-grade performance. If we don't have the smart sensor you need, there are input options for connecting third-party sensors with either analog outputs or pulse outputs. We'll look at each of these areas in more details on the following slides. Our smart sensors are the easiest to use because when you plug them into our loggers, the logger automatically recognizes what sensor you have plugged in, and it will record the data for that sensor with the proper units. Our sensors are good quality, research-grade sensors suitable for most weather station applications. One thing to note about our sensors is that they are fully specified, so you know that the accuracy is as specified. Our specs are system-level specs, which include the accuracy of the sensor as well as the A to D conversion accuracy. This is important to keep in mind when comparing our sensors to other sensors which give an accuracy for the sensor only. For these other sensors, you have to add the error for the analog measurement circuitry on top of the sensor accuracy. If we don't have the smart sensor you need, your next option is to use a third-party sensor with an analog output connected to one of our analog input options. There are basically two options for connecting analog sensors. If you are using one of our U30 stations, then your best option is to order it with the analog sensor port, which has two inputs which can be programmed as either 4 to 20 milliamps or voltage inputs. This port also provides sensor power suitable for most sensors. We also offer analog input adapters which plug into our smart sensor inputs on any of our stations. Connecting sensors to either of these analog input options does require a little more work because you need to connect them properly to the screw terminals and you need to enter scaling information into the logger. But the advantage is that you have almost an infinite number of sensors to choose from. The other type of sensors that can be connected to HOBO stations are sensors with pulse outputs, such as rain gauges and flow sensors. These can be connected to our pulse input adapters shown here. For example, you can connect to a high-end rain gauge designed for high-intensity rainfall events. To connect it, you just need to connect the two wires from the adapter to the screw terminals inside the rain gauge. You would also need to enter scaling for tip sizes into our software. Once you've determined what sensors you need to add up how many inputs and channels you need at each of your stations. In doing this, you need to understand that one smart sensor can actually have multiple parameters, in which case it's going to use multiple channels. In this chart, you can see the number of channels required for typical sensors. So for example, the temperature sensor just is one channel, temperature humidity channel, or temperature humidity sensor requires two channels, one for temperature, one for humidity. Our station loggers are all limited to 15 channels, so you have to be careful to add up the number of channels and make sure you're within that 15 channel limit. In terms of the number of inputs, we have stations available with 4, 5, or 10 sensor inputs. A breakout box is also available for adding more inputs to a station, but you are still limited to the 15-channel limit. If you really aren't sure what parameters you are going to need at your site, here is a good typical weather station sensor set that you could start with. This one will provide temperature, humidity, wind speed and direction, and rainfall information. You can easily add more sensors later as you learn about your site conditions and your needs. The next question we will look at is, what options do you have for accessing your weather data, which will help you determine what data logging stations you need. Basically, our weather stations can be divided into two categories based on how you access their data: web-enabled systems and standalone stations. The web-enabled systems can be accessed and managed through the Internet using either cellular, Wi-Fi, or Ethernet connections or communications to get the data onto the Internet. The HOBO standalone stations store data into their memory, and you have to go out to them to retrieve their data, and you need to set them up using a desktop or notebook computer. Let's look at our web-enabled systems first. The main benefit of web-enabled systems is that you can access their data anytime from any web browser. All you need is your username and password to log in. They can also send alarm notifications to your cell phone when conditions go outside limits that you set. Another benefit of our remote monitoring systems is that they can notify you if there are any sensor or system problems. These notifications allow you to go out and fix the problems as soon as possible before any critical data is missed. Here are some specifics on the HOBO U30 system. It provides web access to your data via cellular, Wi-Fi, or Ethernet communications to the Internet. It has a rugged, double weatherproof enclosure tested to NEMA 6 standards. It uses solar power to recharge its internal battery. It comes with either 5 or 10 sensor inputs, and you can set up multiple levels of alarm notifications, each with its own call list. It's pretty reasonably priced, and one thing to note about the cellular plans is that includes the cellular transmission cost. Mobilink is our Onset hosted solution for viewing current conditions and trends via the web from your U30 stations. You can also do your system management with Mobilink, such as setting up alarm notifications. It also provides full access to all historical data from all your stations for analysis in our HOBOware software or in your favorite spreadsheet program. The data can also be accessed from Mobilink with programs that you write using web services, or the data can be forwarded to Weather Underground if you want to take advantage of Weather Underground's display and data sharing capabilities. Now let's take a look at your options for standalone stations. HOBO standalone stations are your most cost-effective option, but you have to go to the station to retrieve the data with either a notebook computer or one of our data shuttles. You can retrieve the data when you do your site visits or at the end of the season. We basically offer two flavors of standalone stations. One is the U30 NRC, which has the same features as our other U30 remote monitoring stations, but without the web access. This station has a USB interface for communicating with the computer. The other choice is our microstation at $220, which has 4 inputs and is entirely battery powered, which makes it suitable for locations without sun, such as under plant canopies. It can run for a year on a set of AA batteries. The best way to offload your data from our standalone loggers is with our HOBO Shuttle, which can offload data from up to 7 full stations before it has to be offloaded to a computer. You can also use the shuttle to check the station's sensors and batteries while you're out there. Okay, now that we've selected sensors and loggers, we need to ask, how should I mount the sensors to maximize the performance? Proper mounting is important for measurement accuracy and long sensor life. A key for good measurement accuracy is good sensor spacing so that they are far enough apart so that they don't interfere with each other. For example, you want your wind sensor far enough away from your rain gauge that it doesn't block rain from going into the rain gauge. And vice versa, you don't want the rain gauge so close to the wind sensor that it causes turbulence. Another key is that the sensor heights are adjustable so they can be set to the heights defined by weather measurement organizations or to position them in the microclimate that you're measuring. Let's look at wind sensor mounting first. The first factor to understand is that wind sensor or wind speed increases with height above the ground. So it is important that you measure wind speed at the same height if you are going to compare data between stations. In this graph, you can see that the wind speed factor increases from 1.10 at 2 meters to 1.17 at 3 meters, which corresponds to an increase in wind speed of 6%. You also want your wind sensors to be high enough so they are not affected by nearby obstructions, unless, of course, you are specifically studying the microclimates behind the obstruction. The reason for looking at wind sensor mounting requirements first is that this usually determines the height of the tripod or tower that you will use. We offer tripods for mounting the wind sensors at either 2 meters or 3 meters. For greater heights, such as 10 meters, you will need to get those from a tower provider. In either case, we recommend using our cross arm for mounting the wind sensor because that provides a way to do the fine adjustment of the sensor height. When mounting wind sensors on our tripods or masts, the mast must be secured with guy wires. This prevents vibration, which is important for accurate measurements and long sensor life. Generally, we recommend ordering our tripod kits because these include the stakes, guy wires, and grounding rod that you're going to typically need. Next, let's look at rain sensor mounting. As we saw with the wind sensor, the wind speed increases the higher you get above the ground, which can, in the case of rain measurement, can lead to greater rainfall loss at the greater heights from splashing in the wind during the storm events. For the best rainfall measurement accuracy, you should mount your rain gauge close to the ground, away from the main tripod and above any splashing. We offer a 1.5 millimeter or meter mast that is good for mounting our rain gauge. You can also mount the rainfall sensor at the top of your main tripod to keep everything on one tripod. If you plan to do this, make sure to order a guy wire kit to make sure that the rain gauge does not shake, which could lead to false tips. As for temperature and temperature humidity sensors, you need to use a solar radiation shield to minimize the heating of the sensor by the sun. If you don't do this, you could get artificially high temperature readings when the sun's out. It is important that the shield is mounted where it gets some airflow through it so it is getting an accurate measurement of the air temperatures in that area. Looking at light sensors, the key with light sensors is that they need to be mounted level to get accurate light measurements. Our light sensor bracket includes 3 thumb screws for leveling the light sensor. You'll also need to have one of our light sensor levels. To use the level, you temporarily place it on top of the sensor while you are leveling the sensor with the thumb screws. And then you got to be sure to remove the level after you're done doing the leveling. Next, briefly I'll talk about soil moisture sensors. The key for soil moisture measurements is to make sure that the sensors are installed properly. And the key for good installation is good contact with the soil around the sensor with no air gaps. When installing these, be sure that you have the proper tools and that you follow the installation instructions that come with your sensors. The tools you'll need depend upon how you will be installing your soil moisture sensors. And to really do this topic justice requires its own webinar, so I'm not going to be going into that today. The final aspect of sensor mounting is to make sure your cables are protected. If your cables get cut or pulled out, you can lose critical data. Make sure that any cables that are running along the ground are protected in conduit. And in some cases, you also need to protect the cables along the mast. Depends upon how aggressive the hazards are in your area. The type of conduit depends upon how, on how bad the hazards are. In most cases, inexpensive split plastic conduit is enough, like is shown here. But in some cases, you may need to protect it in steel conduit. You also want to avoid having any loose wires flapping around on your weather stations because these wires flapping in the wind can pull on the sensor connections and lead to failures over time. Gather up any loose wires and zip tie them to the mast and mounting arms. You can see a pretty good installation shown here. We even offer a mounting accessory called the cable caddy for gathering and protecting any extra cable you have. Okay, We're down to the final question, which is how much will the system cost? Price is important because if you can keep the cost down per site, you can monitor more sites and get a better picture of what is going on. Here are the price ranges for the various components to our system. I think you will find our prices are pretty reasonable for research-grade systems. As you can see here, there are a wide range of prices for our stations, sensors, and mounting systems. I'm going to look at a couple of specific examples on the next couple of slides to give you a better feel for what a full system might cost you. Here's an example of a typical standalone station based on our microstation. This one includes temperature and humidity and a soil moisture sensor. It's mounted on a 2x4 for mounting, which you can buy locally. It also includes a solar radiation shield for your temperature humidity sensor. And altogether it costs just over $600 with the sensors and mounting. Plus you also need to have one copy of our software and an interface cable for communications. I'd also recommend a HOBO Shuttle for data offload. Here's kind of the other extreme, a weather station with cellular communications and web access that monitors rainfall, solar radiation, temperature, and humidity. When you're looking at this, note that the U30 includes the cellular communications, battery, and antenna all integrated together in a weatherproof enclosure and is purchased as a single unit. All you need to add to that are your solar panel, sensors, and mounting accessories. If you, in this case, you add this all up, it comes up to just over $2,000. You also need to add to that a calling plan, and in this case, the example is a 20 call per day plan, which is $300 for a year, which is $25 per month. So these have just been a couple of example configurations and costs. To get pricing on any of our products, you can go to our website, which has complete pricing for all of our products. We're proud of the value we offer, and we put all of our prices on the web so you know what to expect. And of course, you can always contact us for quotes on systems that meet your specific needs. Okay. Just to review, these are the 5 key questions you need to ask when configuring a HOBO weather station. If you can answer these questions, you should have a pretty good handle on what you need. So just to recap, the questions are, what are the advantages of having site-specific weather data? What parameters do I need to monitor? What options do I have for accessing my data? How should I mount the sensors to maximize performance? And how much will the system cost? Okay. Now that I've spent most of the time talking about the 5 questions, I have some time for your questions. So let's see. Okay, I'm just reading through the questions. The first question is, how does a HOBO Shuttle interface with a standalone unit and with a desktop computer? The HOBO Shuttle actually comes with a couple of communication cable options because our stations actually have different, in some cases, different communications. The microstation has a serial interface, so for that station, you'd use the serial interface cable that comes with the HOBO Shuttle to talk to the microstation and offload the data. And it's got push buttons that initiate the offload when you connect it up. Then when you take it back to the computer, you hook it up via a USB cable back to the desktop computer. In the case of the U30 stations, those have a USB interface, so the HOBO Shuttle also includes a USB interface cable, and it goes interchangeably between those. Okay. Let's see, what else do we have here? Okay, the next question is, I'm planning to put the weather station on the roof of my building, and I don't want to put any holes in the roof. Any suggestions for mounting? And then the roof is flat. This is a pretty common situation. There are a couple of methods you could use. One is to bolt boards to the feet on the tripod, and then place, and then when you put the tripod on the top of your roof, you place heavy cement blocks on top of these boards. This is especially good if you're going to be deploying the weather station for a short amount of time, such as a week or two, as part of like an energy performance study. Another possibility is to find a structure on the rooftop that you can mount one of our masts to the side of that structure. In either case, if you're mounting a wind sensor on top of the mast, one of the things you want to keep in mind is you should use guide wires to make sure that that doesn't vibrate. As I mentioned before, you don't want to have your vibrations in your wind sensors, which could affect their durability, how long they last over time. The other alternative is to use a very stiff mast that doesn't flex, or to keep the mast very short is another option. So, okay. Here's another question. Do you have any output options like contact closures for your web-based systems? And the answer is yes, but limited. Our U30 system has one relay output in it, which can be used to turn on like an irrigation system, for example. We have a lot of users that are using them in conjunction with temperature sensors as frost alarms. So when the temperature goes below a certain level, like 35 degrees Fahrenheit, it'll activate that relay in the U30, and that relay can be connected to the irrigation system to turn it on, and it turns on the sprinklers and protects the crops against frost. So so the answer is yes. Okay, the next question is, what is the cost of the program to access data? There's actually, I should answer that two ways. There's the desktop application, which is called HOBOware, and we'd usually, for our stations, we'd recommend the pro version of that, because that is required actually to launch our HOBO stations. And the cost for that is, if you do the web download, it's $89. If you buy it with as a CD with the interface cable, it's $99. So for under $100, you get your desktop software, which is a pretty powerful package. It can do graphing. It can combine data from multiple loggers very easily in multiple deployments. You can zoom in and do some simple statistics on different parts of the graph. It's a pretty nice desktop application. Now, in the case of our remote monitoring systems, those are accessed through our Mobilink web interface. And so there's no separate software you have to buy, but you do have to subscribe to the Mobilink web service. And in the case of Wi-Fi or Ethernet communications, we've got some free plans which allow you to access the data from your stations and look at the data graphically, real-time graphs, and offload the data from your U30 stations. And in the case of cellular plans, the plan also includes the cellular transmission cost. So those plans are a little bit more expensive because they include that. But that one price for your annual subscription of Mobilink includes all that graphing and data access capabilities. You don't have to buy any separate software in that case. Okay. Yeah. Some questions about sensors that are available. One question is do we have a barometric pressure sensor? And the answer is yes. We have a barometric pressure sensor, which is part of the system. It's just one of our standard smart sensors, and you can plug that in, and it recognizes it right away. Another question was about ultraviolet radiation sensors. And we have two types of light sensors, but not an ultraviolet light sensor. We have a PAR sensor, which is photosynthetically active radiation, and a solar radiation sensor, but not ultraviolet light at this time. And for that, that's where you'd want to look at using one of our analog input options and connecting up a third-party sensor, which has a 4 to 20 milliamp or voltage output for ultraviolet light. Okay, here's one. I suspect this is from one of our somebody outside of the U.S. because it says, does the HOBO cellular service work in other countries? Does it require a computer nearby to pick up the data so it is accessible remotely? Okay, two parts. Yes, we have an international service plan, which we call it our World SIM, and you buy that station, and you can actually take it from country to country. And we have the full list of countries that it will work in on our website. But certainly most of the European countries are covered there. Some in South America. I'm sure I'm leaving some out. But yeah, the full information on that is on our website. And what was the second part? Oh, yeah. Oh, the second part of that was, does it require a computer? No, because the U30 includes its own communications to the Internet. So just to make that clear, it captures the data, and then if it's got the cellular communications option, it's sending that data through GPRS to the cellular network, and that sends it directly to our server, which has the HOBO link running on it. And then you just need to access that through your web browser. You don't need to have a separate computer to get that data onto the Internet. It's integrated into the U30. Oh, yeah. Okay. Here's another good question. Can you import weather data from other sources into HOBOware? Yeah. As a matter of fact, you may remember that graph I showed comparing the weather data at the nearest airport to the weather here at Onset. That was actually data that I went to the nearest airport, which is in Hyannis here on Cape Cod, and I downloaded the data from the airport. I think it was a National Weather Service station, and you can easily import that, or pretty easily, I should say, import that data into HOBOware and analyze it with your data that you get from your HOBO station sensor. So once you bring it into HOBOware, you can actually save that together as what we call a project file, which includes both your HOBO station data as well as any data you've imported, and you can save that and analyze it later. Okay, can you describe, here's another question, can you describe how the U30 Wi-Fi connects to the web? It's, what is that standard? It's basically like your standard Wi-Fi that you'd have in your notebook computer. So if, in most cases, if you can get Wi-Fi coverage with your notebook computer, you're probably going to be able to get Wi-Fi coverage with your U30 Wi-Fi. Yeah, so you need to have a Wi-Fi router that's within the range of your U30 to receive that. And then you do need to set up the U30 when you first get it to link it into your local router. So that's one thing you should be aware of when you're using a U30 with Wi-Fi. You need to link it into your local network. Just download a couple parameters that you would get from your network administrator, and once you've entered those in, you should be able to just power up your U30 Wi-Fi, and it should start sending data to the Internet. Okay, I think I've got time for one more question, and let's see, we'll go with this one. What is the power source of standalone weather station? Okay, our standalone weather stations are battery powered, and basically, as I mentioned, there's two flavors of our standalone stations. One is the U30 NRC, which is that one is powered by a rechargeable battery, which gets recharged by a solar panel. So with a U30 NRC station, you need to buy a solar panel plus the U30 NRC, and then it recharges the battery. In the case of our micro station, that's powered by 4 AA batteries, which get installed into the logger. We include the batteries with the logger, of course, and those are good for a year of use in most cases, and you just need to replace them at the end of the year. Okay. I think at this point, I need to wrap it up. So thanks for those questions, and I see there's some other questions here. And what I'll do is, for the questions that I didn't get to, I'll follow up with you afterwards by email. So give me a few days. I see quite a few questions here, so it may take me a little bit to get back to all of you, but I promise I will get back to you. And there is a couple of additional slides that I want to go through before I sign off. First off is next week we'll send you an email with a link to this webinar so you can refer back to it. As well, you can share that link with your colleagues. So if they didn't get a chance to sit in today, they may be interested in this as well. They can watch it. And I also want to mention that we have a wealth of resources on our website that you can take advantage of. On our website, you can find white papers on selecting and deploying weather stations, as well as webinars on using our software and setting up weather stations. Here's some contact information. If you have questions directly relating to this webinar, please feel free to contact me. You see my contact information there. If you would like help configuring and ordering a system, you can contact our application specialist. You can see their contact information there as well. And if you need help with a system that you already own, you can contact our technical support group. Well, that wraps things up for today. Thanks for attending. And going back to my original ice cream analogy, if you ask yourself the 5 questions, you should end up with that perfect weather station that is the ice cream sundae that you've been craving. So thanks again.